Peru is located in South America, along the eastern boundary of the Pacific Ocean basin. And despite its tropical latitudes, its coast is kept cool by the process called coastal upwelling, by which the force of the trade winds pull up cooler, deeper water to the surface. And this cold water is also loaded with nutrients. So this process maintains one of the richest marine ecosystems in the world. It also has a profound effect on the climate of the coast of Peru, not only by maintaining relatively low temperatures, but also by suppressing rainfall so that the coast of Peru is pretty much a cool desert. However, we know that the climate is not static, and few places in the ocean basin have a climate variability as strong as along the coast of Peru. Year to year, the coastal ocean water temperatures fluctuate between cooler and warmer than average, that is between La Niña in cool cases and El Niño in the warm cases. During extreme El Niño events, the arid climate of the northern coast of Peru can become as warm and rainy as the one we can find in the Amazon rainforest. And also the marine ecosystems can be severely affected by these events. The most destructive El Niño events in that sense were in the years 1983 and 1998, and the warm ocean temperatures were not only along the coast of Peru, but also all the way along the equatorial Pacific into the central part of the basin. And furthermore, in the 1983 event, as well as also during a similar one in 1878, the El Niño produced severe drought in the Andes mountains of Peru, in addition to the heavy rainfall along the coast. Now, the underlying physical mechanism of these El Niño events involves in a fundamental way the interaction between the ocean and the atmosphere, by which the ocean warming in the eastern Pacific leads to winds blowing from the west to the east, which in turn leads to more ocean warming, and this in turn to more winds from the west, and so on in what we call a positive feedback loop. So this is why this coupled ocean atmosphere phenomenon is called El Niño Southern Oscillation, or ENSO in short, where southern oscillation refers to an atmospheric variability pattern. Now, every El Niño event has its own particularities, and the details of how the ocean behaves in each matter for the climate effects on Peru and elsewhere. For instance, we know that not only the ocean warming right next to the coast can produce heavy rainfall there, but also that the warming in the central equatorial Pacific tends to reduce rainfall in the Andes mountains of Peru. And each El Niño event can combine these two effects to different degrees. Now, for instance, the third strongest El Niño in terms of the impacts in Peru was in 2017. But since the warming was restricted to close to the coast, while the central Pacific remained relatively cool, only Peru recognized this as an El Niño event at the time. This 2017 event was very similar to the ones in the years 1891 and 1925. Now the scientific community calls this type of event a coastal El Niño. And we know that it also has the interaction between the ocean atmosphere at its core, but rather than the west to east winds that we have in the case of ENSO, this type of event involves more of a north-south wind. So, and it's also more localized and much faster. So understanding this mechanism is key to be able to improve our capacity for prediction. Therefore, monitoring and studying this coupled ocean and atmospheric system is key to forecasting El Niño in general and avoiding its worst impacts. Particularly the long-range prediction of the coastal El Niño remains an important and exciting scientific challenge. Furthermore, with climate change, the frequency of extreme El Niño events is expected to increase, making this an even more urgent matter.